Hello, friends of software entertainment, and welcome to a new live session here. And everybody of us developers is asked the questions: how will run your infrastructure when you have a Superbowl advertising? And today we have here one guy who can answer how much traffic is on it, if he can watch the game, and what kind of advertising they published and what comes around for infrastructure. Warm welcome, Farhad.
Hi, it's great to be with you guys today. I'm very happy to be here and share our experience about the Superbowl event that we had, the ads that we ran, and the traffic that we got. But a lot of work had to be done before that, and we will talk about those as well, hopefully. So there would be like a lot of interesting gotchas, a lot of problems that we faced, and a lot of things that crashed that we will talk about. So hopefully, when you have your event, that you're going to receive a lot of traffic. You're much more prepared after this talk, after this session that we have with Poland, and yeah, it will go much more smoother for you guys after this.
What is about you? From what town are you coming?
So I was born and raised in Tehran, so I'm Iranian, yeah. And 8 years ago, I joined Adjoe, a startup in Hamburg.
Okay.
It was since very beginning of the Adjoe. So it was just formed. We were like 4 people in the office trying to build an MVP and enter the market. So yeah, since the beginning. And I would say it was a long and very interesting journey. And now we have like more than 400 people here.
Unbelievable.
Yeah, it grew insanely, and it's like it's been a very nice journey for us. But maybe a little bit about Agile, so you guys understand that. Okay, why do you even need to scale this much, and what happened? So it all falls into the place in the end. Yeah. Adjoe is an ad network, and we have two sides of the business technically. So we do mobile advertisement, and these two sides of the business are mobile apps. There are some apps that want to acquire users, and there are some apps that have a lot of users and they want to monetize them. For example, you can think about any app developer that want to grow their app. So these are one side, and the other side are those apps that already grown and they want to make some money, and by monetization and showing advertisement to their users. And we have a lot of machine learning, a lot of AI and cool stuff going on there to be able to connect the right ad to the right person, to make the users happy, the demand side, which is the side that want to buy the users and get put the advertisement campaigns on, and also the supply side, that is the side that has the users and wants to monetize them and make some revenue happy.
So this all are real-time data. So
Yeah.
when I come in, they know I'm here from Duisburg, and yeah, maybe there are much more information about me in the browser, and what kind of PC I'm using, and all the stuff. And this information you get, and then you also prepare the right advertising for me as male target group and for female target group. And this is all, yeah, maybe let's ask the questions on a Super Bowl event on this advertising. Sometimes I think when you are watching a game or have this pause between the game, then are the people opening the pages that are shown on this advertising? So do you see now it's live, and then you have this peak?
Yes. So the thing is, our advertisements are a little bit different. So they are not like a web page or something. The advertisements are usually in the mobile apps. So the apps that have a lot of users, they show those advertisements, and the users do something. This event was a little bit different. One of our partners in the US secured an ad placement in the Super Bowl and in the Super Bowl event. And this, based on this ad placement, they had a QR code shown in the Super Bowl. And based on the number of the users that
can win something or like this.
Exactly. They were like cash rewards, and there was a lot of incentives for the users to scan that QR code and get to their app. And from their app, they would get to our
user registration and all the stuff.
Exactly. Yes.
But this is super hardcore, I think.
Yes, it was like multi-team, multi-company effort to make this happen. That's why it was like really, there was a lot of coordinations between different teams, different companies, and also a lot of development, a lot of performance testing. It was really big, but we get to that. What do you
mean when I say, hey, Never Code Alone is sponsor the Soccer World Cup or something like this? First German game or anything? How much prepare time you need, or do you say, hey, this Never Code Alone application, this will never run on World Cup, or do you host then the application, or what can I say? I think I know a lot of shops, but I think this are 20,000 direct users or something like this, what are registering, or do you know how many people registered in this evening?
Yes. So the thing is, when you're preparing for an event, you need to get some statistics, like how many people are watching that event, and based on the number of people that are watching that event, your teams would calculate based on the drop-offs and how previous events, how many people would, for example, scan that QR code, how many people would start downloading the app, how many people would get to the point that it starts reaching your backend, for example. Yeah. And how much time do you need to prepare? It depends on your application, of course. I cannot really say, but I will talk about our application. I will show you some diagrams later on that shows different parts of the architecture that we had and what problems per piece we had there. So you guys know that, okay, what kind of problems actually happen. So just to give you a rough idea, yeah, that's how much requests we are expecting. Based on the event, our partner was showing a live stream. So they would do the QR code, they will download the app, they will get to a live stream in the app. Yeah. And that live stream would go for some minutes. It will collect all the users. That means that, okay, the live stream will get them engaged. They're there. And then they would release these users over a very short period of time to our backend. This would make a huge bursty traffic that would be probably much less if the event was not like this. So it was very special. It's not only that Super Bowl has like a lot of viewers, like millions of viewers seeing that. It's also the fact that, okay, they wanted to collect the users and send them to an app in a very short amount of time. Yeah. And it would be millions of users in a couple of minutes, technically.
Wow.
Yes.
And you also have much more challenging. You also have the traffic because in the week before, I think the advertising is also published on YouTube, and this will be the Super Bowl advertising. You can see this on YouTube. So I think you will also have a lot of traffic in the week before and in the weeks after.
Yes, of course. Weeks before, no, because the advertisement would start at the Super Bowl event. But of course, that app that is doing that advertisement is doing all they can to increase the retention of those users that they are acquiring using that ad, obviously. Yeah, that means that, okay, on the weeks later, we would also receive more traffic. But just to give you a rough estimate, we usually have around like 1,500 RPS, like requests per second on our backend services. And we were expecting 1,000 times more there. So I just want to explain that, for example,
per second,
now,
guys, yes, out of there per second, not per hour. per second. This is
Exactly. Just some ideas again about Adjoe. We have integrated more than 1,000 mobile apps around the world. Those are our partners, and of course we are doing monetization and advertisement in those apps, and we have more than 800 million mobile users annually. So there is we have a lot of users around the world already, and usually we help our advertisers to achieve higher ROAS, we call it, the investment, the return on the investment that they get. Let's call it, for the people that are not in the ad space, and that means that they make usually more money. That's their incentive to integrate our platform, and of course, we are one of the top ad networks in the world, always appearing on the top placements in different global rankings. And we have offices all around the globe. For example, we have in Hamburg, the main office, in Boston.
But you are a German company, can you say? Or are you only
Yes.
based in? Yes. So
Yes.
this is not that IT in Germany is every time lame, and this is spectacular. So go around, eat there, make a lunch break with the team, ask them things, connect with these people, follow on social media. This is spectacular.
Of course, the company originally is from Hamburg, so it's a German company, of course. But now it's we have different offices in different parts of the world. As I mentioned, Hamburg, Boston, Singapore, for example, Tokyo, Amsterdam, and so on and so forth. So there are offices all around the world.
Did you already visit one of these? Or can you
me myself? No, I didn't. But usually
somewhere else. When you say, "Hey, let me work for 2 weeks in Singapore," could this be possible?
I believe that is possible. I haven't done it yet though, because my team is also mostly in Hamburg. So for me, it doesn't make much sense. But different teams that are living in different parts of the world, they visit each other all the time, for sure.
Spectacular. Okay.
Yes. So that's really cool. Now, I mentioned that we are a German company, but this doesn't mean that we have only German people working here. We have people from different continents, almost all the continents, and we have, I believe, people from more than 60 countries in the world that are working. So this is super international culture in the company, the building blocks of the company, I would say. So
is the main part IT and development and DevOps engineers, or what you say?
It's both, but we consider ourselves as a tech company. So yes, the main part is tech, but of course we have business teams that they are doing amazing job and actually making the business work. So
what is the fastest programming language?
Okay, you're gonna get me in trouble. So I have my opinionated opinions as well. So
what
I would say what's my favorite.
What kind of program languages are used for? So what is the language?
Adjoe.
Okay.
You mean in the company? Yeah.
Yes.
So for Adjoe, we mainly code in Golang, but we have different other.
Something like Go for this high performance.
Yes, that's amazing. Go is amazing, and we also use Rust for some high performance services that we need to have better performance. So we have Rust, Go, and for all the
C
machine
also,
learning.
maybe.
C we don't use much, but maybe a little bit in the mobile side in the SDK. So we use Kotlin, Java, maybe a little bit of C. And for the machine learning and all this AI stuff, we of course use Python. Sometimes a little bit of Scala with Spark as well.
Spectacular tech stack.
Yeah, there is a lot of stuff going on. A little bit of metrics about how much load, because I said that we are an ad network, and ad networks usually have a lot of traffic coming in. As mentioned, there is 800 million mobile users that are using our platform. So you can imagine how much API calls are coming in. It's usually around 6 billion API calls daily right now, and we have more than 600 terabytes of our data lake that these models get trained on. And for Superbowl, we were expecting that we would receive 150,000 requests per second over 15 minutes of time. That means that, okay, this live stream goes on that I mentioned, and then we collect millions of users and they released 150K per second to our backend that we need to process them.
These are maybe also that you promise some kind of requests per second for your clients. So maybe this is the point now to share a screen, or
sure.
What do you think?
Yes, I can show some diagrams maybe, and here I will discuss a little bit about our architecture that we had before the event, and what went wrong. I will go step by step and discuss with you.
Cool.
Nice. So I'm not sure if you guys are currently seeing the diagram. If you're seeing it.
So we have 30 viewers here. When you have any question, ask the question. When you just say hello. This is also a good thing for us that you are living out there, but we also know that developers do not make the most of the comments. But I see here the backend.
Yes. So as mentioned, we have like the mobile side that is like developed in Kotlin and other technologies, for example, Swift for the iOS, and the user is scanning, for example, that QR code or using one of our partners' applications. And then the request from that mobile device reaches our backend. We have two sides. One side is just for the static resources. You can see Amazon CloudFront. So we are basically here using AWS services. For CloudFront is just a CDN for the people that are not familiar with it.
Yes.
Exactly. So all the static resources we host there, and whenever a request is for a static resource, it instantly gets responded by CloudFront closer to the user from the edge location, and it will be done.
Is this also then using a kind of detection on what country you are, and that it comes from this country?
Exactly. Okay. Exactly. So CloudFront, like any other CDN, they have like edge locations in different parts of the world, and the data will be served from the closest location to the user. And the main part is the application load balancers that you can see on the bottom side. This application load balancer acts as an API gateway for us, and it decides that this request that we received, which microservice in the backend should receive that request, technically. Yeah. So it's a load balancer like any other load balancer from AWS, and decides based on the request that who should receive it on the backend, this request. And then we have the ECS cluster. It's very similar to Kubernetes from AWS, but much simpler. Back in the days, we were using ECS because it's really easy to set up and to scale. And we have, of course, auto-scaling there as well. And
on the Superbowl, yes. On a Superbowl, is there a pre-scaling that you say, hey, we need 1,000 databases pre-built? Okay.
Yes, I will discuss all of that. It's like there is a lot of stuff that we need to do to prepare the system for the Superbowl traffic. Yeah. So this is the 1,500 RPS system right now, not the one that would have like 1,000 times more traffic. So then the microservices are running on this ECS, and the ECS is also backed by the EC2 instances. EC2 instances are normal servers, let's say, that AWS provides. So they are the compute engines that run the containers there. And our backend application is like mostly Golang, containerized, microservice architecture with event-driven design. Yeah. I say event-driven design because we have then SNS and SQS. That's how asynchronously the backend applications will, these backend microservices will send data and communicate with each other. So in microservices design, we usually have stateless services, but we need to store the state somewhere. And that's why we have at the bottom the databases that you can see. DynamoDB, a NoSQL database from Amazon, and it's highly scalable, and also Elasticache, which is technically Redis from Amazon that we were using. We have also some streaming platform, which is Kafka, and we stream the data to the S3 and to a Columnar database, which is Druid, which we run on Kubernetes. So Kafka and Druid, we host ourselves on our Kubernetes cluster for streaming the data to S3, and to Druid, we use Kafka. And why
Is
do
there
we
nothing
use
going?
Yes.
Is there nothing going back, like a session ID or something, that the user always go on this own session? So
Yes.
I
So
see now
so we,
all
yes.
the arrows from the left to the right, but is
Yes.
going some information maybe also back?
100%. So this diagram doesn't show that, yeah. But of
And
course,
the
the
cookies and
responses
all this marketing things.
exactly have all of the stuff. So all the responses in the end, when the application processes the request, will go back to the user mobile device for sure. Yes.
Okay.
And I just wanted to emphasize that why we use Druid, because we have a lot of data and we have a lot of aggregations, and we need to make sense of this data. We use Druid for the queries that have a lot of group bys. That means that, okay, for example, I want to see how a campaign is performing based on the age, gender, and, for example, the country of the user. Then I need to group by the raw data based on that. And that's why we are using Druid. And in the end, Druid will power our dashboards, our real-time analytical dashboards that our account managers and our clients will understand how their campaigns are performing, how their app is performing, and what's going on, and make sense and optimize everything. So that's why I put it here. Of course, we have a lot more services, but these are the services that are affected, and we need to technically be able to scale them for the Superbowl. The rest is kind of on the back. For example, the machine learning and all the stuff that we do with the AI, and the rest of the AWS services, and also open source technologies that we use. That's why they are not in diagrams. So the diagram would be much more complicated in the real world scenario.
Okay.
I mentioned already a couple of open source technologies that we are using, Druid and Kafka, for example. We use much more that are not involved in this diagram, and we are also enthusiastic about open source. Yes, and yeah, for sure. And we are very enthusiastic, and we are also, how do you call it? We help the open source community by pushing back, and also exactly we contribute to the open source technologies. For example, for Druid, there is a Kubernetes operator that Adjoe maintains right now. So we are one of the maintainers of this operator that helps you run Druid on Kubernetes. We have contributions to Druid itself. We have contributions, for example, to Prometheus and other open source technologies as well.
Perfect. This is a good social media topic, maybe for Valeria, if she's in the chat. Welcome.
Amazing. So let's a little bit discuss that. Okay, what can now go wrong, and what should I do? Yeah. So in the preparation, technically, we need a load test. Yeah, we need to stress test technically the system to make sure that, okay, which parts of the system will break.
You make it with locust, the easy locust thing, or what? No.
Yeah, we do it with load testing, technically. Yeah, with stress testing. So there is an open source tool called K6, which was very interesting to us and helped us a lot, from Grafana Labs. So you guys probably already know Grafana. If you don't know K6, it's another open source technology that they do. Yeah, that's because we use a lot of stuff from Grafana Labs as well, like Prometheus, Grafana, and so on and so forth. We thought that, okay, this would be a nice integration to our system, and we integrated K6. We started writing our load test. That means that, okay, we figured out what the user behavior would be based on the actions that the user would do based on the ad. And then we started, based on the numbers that we got, write the load test and start performing it on a separate environment that we prepared. So we prepared an environment like a production environment in another AWS account, and we started stress testing it with K6.
Okay.
What happened is that with that environment from 1,500
But you need
RPS,
also the same infrastructure for the stress tests than the application is. Yes, you need super much server
exactly,
power to.
exactly, and
But
it's
then
a
you
lot of
make
cost of
different
those.
kind of mobiles and so on. That's you also check this if it works on every smartphone.
I mean, we did that, of course, but the main part is done by K6. So K6 is technically the test that we wrote is like simulating a mobile device, but just doing the API calls to the backend. There is no real mobile device that does this, but we did the calls that we expected each user would do to the backend, and then we try to scale it to 100,000 users technically per second that they wanted to release to us during the Superbowl thing. Yeah. So what happened is that we got to 10,000 RPS on our first try, and we couldn't go higher than that. And we wanted 150K RPS. So we were so far behind. So let's discuss that what can go wrong. This is not in, so maybe I can discuss our loop that we did, the development loop that we did. So we first wrote a stress test, we run the stress test, and then we watch the metrics. We see the bottlenecks, what crashes, what breaks, and based on the metrics, we try to fix that and move on to the next run of the load test.
So where is the user registration? When I'm client, I'm never code alone. I have my database somewhere, and where's the connection for the new users? So the new users are actually first stored by you in this Amazon DB. That the user is Roland Goller, and he wants to have this QR code benefit, and then later you will bring this to the application from the client, or how is this working?
Yes. So, of course, the DynamoDB will store the user data, but the user data is not an actual user data. So we don't store real data from the users in Adjoe. So the mobile applications send us some identifiers from the users. So it's like some hash, and we don't know an actual user. What we can identify that, okay, this is that user, technically. So we really don't have your data. We don't store any user data here.
But he will enter data to make this campaign successful. So you have the QR code, and then you say register here with a Google account or whatever.
Yes, this is in the application itself that is advertising itself. So we are an ad network. We don't receive those. So we get some identifiers about the users, so we don't know your email, for example.
Okay.
Yes. So we get some identifier, some hash that it's unique to you, and we cannot really map it to you, technically.
Okay.
This is for user privacy. Yes, it's very important for us to make sure that users' privacy is ensured in our application. So yes, let's move on. So a lot of parts of these parts of the system that I'm showing on this diagram will break when we are iterating through this load test loop, this stress test loop that I mentioned. And let's start from the beginning. It's not like that. For example, if I start with load balancer, it doesn't mean that on our first try the load balancer broke. But I want to make sure that we start from the beginning to have a little bit of storyline to it, yeah. So you guys understand, what do we do with each part of the system? So for CloudFront, we just had a discussion, a chat with the Amazon support, and they were confident that we don't need to do anything here. So CloudFront, because it's a CDN, they already receive a lot of traffic and it's fully managed. Nothing's gonna happen. They said that it's good. So we were good to go here. Moving on to the application load balancer, we had some issues here. So we were doing our load tests, and at some point we were seeing that some requests are like just not hitting the backend, and we were confused that why it's not getting there. And then we started a little bit of studying up about load balancer, and also discussed it with the Amazon support to make sure that how should we scale this. So there is two things that we need to understand about the load balancers. Load balancers work on load balancer capacity units. We call them LCUs. Yeah, and these scale based on the number of, for example, new connections that you receive, the number of active connections that you have, the amount of data that is being transferred, and so on and so forth. And load balancers in the back, like Amazon also scales its load balancers. That means that if the load balancer is not receiving a lot of traffic, or it's receiving a lot of traffic in our case, like 1,500 requests per second, and then suddenly we want to receive 1,000 times more, the load balancer will crash. It cannot handle that request. So two things that we need to do. One thing is that we need to reserve the LCUs. That means that, okay, you pre-warm the load balancer before your event starts, because you know that the peak, the spike is so big that the auto-scaling on the load balancer will not support it, and the load balancer will crash. That means that, okay, you reserve these LCUs previously. But with the chat that we had with the enterprise support, they said that, okay, based on the amount of the request that you're expecting, one load balancer is not enough. Means that, okay, you need to load balance your load balancers, technically. That means that, okay, instead of one load balancer, we sharded our load balancer into 3 load balancers. Yeah, that means that, okay, we made it 3 times, we scaled it to 3 times technically. We can handle 3 times more the traffic, and also we reserved the LCUs to the maximum on all 3 to be able to support this event. Mm-hmm. Or if we haven't done that, when the users are getting released to our system, our load balancer will crash, and it wouldn't be a great experience for our users. That means that, okay, the users cannot reach a backend. First, gotcha. I move on to the next part, which is the ECS. Yeah, so we have auto-scaling also, like the application load balancer that has default auto-scaling. AWS has auto-scaling on it. ECS, we have our own auto-scaling on our ECS tasks, which are the microservices that are running the backend. That means that, okay, whenever the traffic increases, we will have more containers running, and we scale up so we can actually handle the requests that are coming in. But again, auto-scaling always is reactive. That means that it looks at some metrics from the previous requests and then decides on that it should scale up. It's not instant. It will take a couple of minutes doing this process, and then it goes back again and again. It's a loop. Yeah, and we didn't have that time. That means that, okay, we need to pre-scale for the event. What we did here is that we figured out, based on a stress test, that how many tasks on each service we need to run for the service, and scale them up beforehand to that amount, like around 1 day to 2 days before we scale them. Why? Because AWS also has limited amount of servers in their data center, and depending on how many users are doing something, like they're scaling, for example, for big events like Superbowl, you need to discuss it with the support months before, to be able to, for the capacity team, to make the decisions for those data centers that are affected by your request, so you can actually request those amount of servers beforehand. So we were in touch with capacity team. They told us that the capacity is there. You just need to request it beforehand, just to make sure that, okay, it is allocated to you before the event and nobody's taking it away. And one more thing, if you guys know about the Spot instances, we run everything on Spot. Yeah, but the Spot instances, of course, are cheaper. That means that we are saving money on that. But there is a caveat. That means that, okay, if somebody bids higher than you, the instance after like 2 minutes will get away from you, like taken away from you, and AWS will give it to the higher bid. That's why for this event, we couldn't tolerate that, and we moved all of the workload that we had on Spot instances to on-demand, to just ensure that the instances that we need are stable and they are always allocated to us. So that's about the whole ECS and scaling.
Okay.
Moving on, we have our message bus, which is SNS and SQS here. We had the problem in the stress test that we saw that, okay, we cannot publish more messages. The problem was a quota issue first, because our account had like 3,000 messages per second quota, which is a default for most of the regions. And we had to go much higher. We increased it to around, I believe, 30,000 with the help of AWS support, but that wasn't enough also. That means that, okay, we were producing even more messages than that. We were publishing more to SNS. What we did at that point, that we had to become a little bit more creative at that point, because we saw that, okay, the more that we request, the more that we need, and the more money we are spending, because per API call that you're doing to SNS and per message that you're sending, you're getting billed technically by AWS, and it's getting more expensive and more expensive. What we did was that we pre-batched our messages for the event. That means that, okay, we knew that, okay, there is a lot of messages we're going to publish. We just collect a couple of messages, like, I don't know, 100 messages, depending on the message size, because SNS and SQS have message size limit. And we started patching them together and compressing them and putting them as one message in SNS. That means that, okay, for example, we reduce the amount of messages that we send by a factor 2000, for example, depending on how many messages you can patch in one message, depending on your size, compression rate, and all the stuff that happens there. So we did that, and then with the help of that, we could actually solve this bottleneck and move on. So we solved the message bus issue as well. The next part was DynamoDB and Elasticache. I mostly want to talk about DynamoDB because that was a very, very interesting. So there is
this is a file-based, no SQL database to store data for, I don't know, the user, the information that you have.
Exactly. You can store whatever data that you want there. So it's a NoSQL database. And we use it mainly because it's highly scalable. Also, it's like quite expensive, but it's really highly scalable and it's perfect for the bursty traffic. But you need to know a couple of gotchas and you need to know your way around it. So what happens here is that DynamoDB works with partition key. Yeah, that means that whenever you want to store some document there, for example, JSON, there, you need a partition key there. And the partition key on the background actually is partitioning the data on their servers. So it's for scalability. Every partition, we can reach 3,000 read requests and 1,000 write requests. That means that you cannot go over that. This is a very important point, because if one of your documents is getting hit more than that and needs more capacity, it cannot scale anymore. It's at maximum. And it is called a hot partition. It's like a common problem. That means that you need to design your database, your table, technically, in a way that it won't become that hot. So you should have enough cardinality and also distribution of the request on your database. For example, if one of your partners have, like, I don't know, 2 million requests per second, for example, you cannot have one document that is response to that and you need to read it all the time. This won't work. This would be a hot partition. And using how do you call it, CloudWatch developer insights, you can find these hot partitions per table. That's what we used in the end to make sure that, okay, we don't have hot partitions. Moving on, there is another gotcha there, that DynamoDB also has auto-scaling on its own and it scales. But this is also reactive. That means that for our case, that is like a huge bursty traffic that goes from 1,500 RPS on our backend to 1,000 times, won't be able to scale in time, and our users will have bad experience. For that, Amazon Web Services offers DynamoDB pre-warming that you need to start doing it at least 2 days before. Yeah, that pre-warming will distribute the partitions to enough servers that you have. I mentioned the partition key, so those partitions will be distributed to enough servers to be able to handle much higher load. So based on your load, you would know how many write capacity you need, how many read capacity you need, space per table you would need, and then you would do the pre-warming for the table on your production tables before the event, just to make sure that, okay, DynamoDB can handle that. Moving forward to Kafka, we had to scale our Kafka, of course. We had to make sure that we run our Kafka also on network optimized instances, just to make sure that we don't hit the bandwidth limit of our network interfaces. And we had to scale our Druid as well to make sure that it can ingest this amount of increased data in the Kafka topics in time, because we wanted our dashboards to be still real time, so people can, during the event, also make data-driven decisions for their campaigns. I think I'm done with the...
There's no application that has an overview about anything.
Overview of what? Like
all these little sessions that it's checking, is the session ID right? There's no software overwatching everything.
Of course, the backend is making sure that everything's right, of course. The backend has a lot of checks. All the microservices are doing all the checks that are required there.
Yeah, maybe there come more slides in the detail.
Yeah, no, that's it. Like I'm done with the slides. Yeah, that's it.
Okay. Cool. Yeah, this is everything you need to see is spectacular. Maybe you show your company page you want to.
Yes. So about the company page, of course, we are always hiring, and we are like growing rapidly, so we need more power in the teams.
What's the target on people for 2026? How many people you want to?
Well, that exact number I do not have. So, but you can always go to our careers page, and our open positions are listed there, and you can always see that which teams are hiring. You can see like it's big, and in different parts of the world we are hiring. So make sure that you are actually
working students. Ask me a few guys on TikTok where students can work. So go to Adjoe.
Yeah, for sure. Please, we are hiring. There is like the teams are really international, really smart, and I think it's a really good opportunity to grow, because as you saw, we have a lot of technologies that we are working with. We love open source. We are integrating more open source every day, and we also contribute back to the open source. I think that's the biggest.
You can visit conferences, and when you say, "Hey, let me go to the Kafka conference" or something like this, then you can join. Yes.
Of course, we have our own conference budget as well. Yeah, that's one of the
spectacular
great things about Adjoe. Yeah.
How hard is it to come for an interview as tech lead?
I don't think that it's hard. I won't call it hard to come for an interview as a tech lead. Yeah, we process all of the applications, and we have different stages that we refine those lists, and then we get to the interview stage. So the TA team is working hard on that, and we have our own processes set up, and they're looking always for the smart people to reinforce the teams.
Okay. Cool.
Yeah. I think this was a lot of technical discussions here.
Yeah, sure.
As I mentioned, really fast, but it's nice that it's a podcast, so you guys can go over later on and see, okay, each part.
Get in touch. We have a lot of information here in the description. When you ask questions later, just in the comments, I will see it and I will give it to Farhad, or get in touch with him, or you will find him on the internet, I'm sure.
For sure. I would love to hear those.
Okay, so we stop the screen sharing. Is this right?
Yeah, thank you.
Yeah, so amazing. What is on your roadmap for upcoming events? When you see, is there something with the Soccer World Cup?
I cannot disclose those, so it's a little bit tough for me to speak about those. But maybe we do another session later on after that,
After
we discuss. Yeah, and
And
we
after the next
discussed a
Super
lot.
Bowl. So after all big events, sport events, you come around and can say your
That would be
learnings
nice.
and what it brings up.
Yes, but what can I say is that, okay, what we learned that we need to do is it requires months of planning. Yeah. In order to not be stressed and plan everything accordingly and do everything in the best way, you need to plan far ahead. Yeah. These things are not like that you can do it overnight or over 1 month period because there is a lot of fixes that you need to do. I talked a
But
little
when
bit
you
about
think,
infrastructure here.
when you see this, and I have an iOS, I have an application or something like this, and I want to make a Super Bowl that you have. Hey, here is a Super Bowl. Here you need the setup. You have this in detail. You have to get the machines warmed up 2 or 3 days before, and this. Where are the months go in the wind?
So the thing is, I didn't discuss anything about the backend application and what you you have to fix there. So you need to do a lot of profiling there as well, and a lot of coding, a lot of application logic changes might be required based on how you designed your application, because it could be the bottleneck as well. And we had a lot of those as well. So it's not just that to fix the infrastructure, is one part. To fix the application code as well, or some infrastructure fixes need application code changes. It's like that means that, okay, it's a multi-team effort to get there, and you need to run this stress test loop many times. So every time you fix something, you run the loop, something else is broken. It takes a long time to
This is
fix
something what we maybe can show here, how you work with this kind of monitoring, how you make a stress test, how you see where an issue is and how to fix this few lines of code for this fine tuning. This
For
could be
sure.
spectacular topic.
Of course, for sure. Looking forward to that.
Maybe the Astro framework is also a high performance framework. Maybe you heard about Astro framework.
Well, I would be really interested to know about it, actually. I haven't.
Maybe we can check in your infrastructure when the Astro framework is doomed.
I need to check that out to see how does it work, for sure.
So good. Yes, I do not have more questions. I want to see more things about this, and this was a super spectacular motivation session for me to see this kind of technologies where I always think, wow, this is super cool when you can say, hey, I manage this. High performance is also a topic. What is important not only for Super Bowl but also to save our world and country, that you need less energy, and performance optimization is also every time good for the world, I think. So Farhad,
That's a great point. That's a great point. I just want to add a little bit to that. That
yes,
is like really important because it depends also where you're working at. Yeah, you can work at some companies that don't have a lot of traffic and you don't get to meddle with this high performance stuff. But when you're working in some place like Adjoe, this is like one of the benefits that you get, production experience with billions of requests per day, and you can make an impact for our world, for sure.
yes, this is a good ending word. So Farhad, have you ever been on YouTube on a kind of screen sharing like that?
Live, no, but there is some conference talks for example, from Code Talks in Hamburg that is on YouTube. So feel free to check
This
them
is
out. And we
also
discuss
where we find us together. Code
Yes.
Talks, spectacular conference, spectacular locations in New Cinema is super cool. Hopefully we meet there this year. So
Yes. One last thing also that we spoke about Code Talks, spectacular conference. There is one more really nice conference, Neo Open Rising conference in Hamburg called Bit Summit. please make sure that you check it out as well. It's amazing. I
Please
attended 2
submit.
times so
Yes,
far.
send me the information. I will sure publish it here on my stream with a few shorts, and yeah, when we get some people, we get some people. So yeah, maybe I know the low-cast Python scripts for making the first steps on performance testing. When you say, hey, you are sitting out there and have nothing to do the rest of the day, what kind of sources would you say is a good entry to get in touch with high performance development?
Oh, that's a tough question.
Yes.
I'm sure that there is a lot of books. So I would suggest finding some nice books from the people who actually worked in places. It's really important. Yeah, like you need to actually verify your sources. So I would suggest finding books from the people who worked in high performance, high load environments. Actually, like the companies, for example, I know, for example, AWS or Microsoft, they have these messaging services and streaming services. Those are huge, these hyperscalers. So I would love to read books from the people who are designing those systems. That means that, okay, you get a lot of information about that. But you can always try to write your application code, and every time you can learn it by experience as well. That means that you every time stress test your own application, and you profile your application at the same time, and you find the bottlenecks and you learn from your own experience. That's also really amazing. That's sometimes what we are challenging with here. That means that, okay, we see that application is not performing well, and it's like, I don't know, millions of lines of code. So you cannot really easily look at the code and figure out, okay, which part of the code should I even look at? Yeah, that's why we have profiling. That means that, okay, I think the entry level for application performance is like that. You need to understand how to profile your application and find a bottleneck. And then at that point, based on the application code on that block, you will learn a lot that what can you optimize to make it high performance.
This is exactly what I want to hear. Yes. Performance monitoring. There are so many specialization around of this high performance cosmos. It's not that you work alone and make something fast. You are like a Formula One team. Maybe have one driver and the team will have the success. So I think, yeah, this was a perfect overview. I think you will come back with more interesting topics this year, because you know now how easy it is to go with me live and to show something. And then I would say massive thank you to you, and goodbye for the community. Here are 2 videos for you. Follow the channel and subscribe. Bye.
Bye.